Hello all, welcome to my new video. In this video, we are going to discuss a very important topic, homogeneity of equation. We often came across many equations in physics like if I write T is equal to 2 pi under root L over G or V is equal to U plus AT or V is equal to length into base into height or density is equal to mass per unit volume. So we often came across many equations in physics, but how can we check whether the equation is homogeneous or not? When the base unit of both sides of equation is equals. Remember, we can express any derived unit in the form of base unit. So when the base unit of both sides of the equation is equal, that is, left hand side is equal to the right hand side, equation is homogeneous or consistent. That simply means that this equation is correct and this equation is homogeneous. So that is how we check the homogeneity of equation. In CAIE question, examiner will give you a equation like the examiner has given you a equation T is equal to 2 pi under root L over G, and then the examiner will tell you the name of the variables, that is T here is time, L is length of pendulum, and G is gravitational acceleration. So he or she is going to tell you the equation, name of the variables, and then ask you to find whether the equation is homogeneous or not. So in a similar way, a second kind of question can also come in examination, like he can give you an equation T is equal to K under root ml cube divided by epsilon. So what does examiner ask in these kind of question? In these kind of question, the examiner will ask that this K is basically a constant and find me the base unit of this constant by telling you all other variables like T is the time here, M is the mass here, L is the length here, and E is the Young's modulus here. So these two kind of questions can come in examination. In this video, we are going to focus on the first type, and in the next video, in past papers practice, we are going to focus on the second type as well. So these two kind of questions can come from this topic, homogeneity of equation. So now let's practice two equations to make sure how we can check the homogeneity. Let's start from this first equation that I have written here. T is equal to 2 pi under root L over G. So we have a practice question here. T is equal to 2 pi under root L over G. We have already discussed that T is time period, L is length, G is gravitational acceleration. 2 pi is just a number and this number has no unit. So we are not going to involve this number in our analysis. If a constant is written, but it is written with a name, it may have a unit or it may not have a unit. And we have to check it whether it have a unit or it doesn't have a unit. But if an alphabet is there, we will check it. But if a simply number is there, we are very confident and we are very clear that this number is not going to involve in our analysis. But in these kind of equations, we are not going to neglect the constant. But where the number is clearly written, we are going to neglect it. And here, we are going to check it. So now, T is equal to 2 pi under root L over G. Let's take the left hand side. The left hand side is T, that is time period, and time period is measured in second, so the unit will be second here. Now let's take the right hand side. So right hand side will be 2 pi under root L over G. So 2 pi will be neglected and we will only remain with the under root. So the power of the under root will be 1 over 2. Length is measured in meter, so the unit will be meter. G is gravitational acceleration and the unit of acceleration is meter second minus 2. So meter will be cancelled by meter. This s minus 2, as it comes upwards, it will be s plus 2. The minus will be changed in plus 2. And then the s2, when multiplied by 1 over 2, that 2 will be cancelled by 2. And what we have in the pocket, we only have s on the right hand side as well. So see, on left hand side we have the unit as second, s, and on the right hand side we have the unit as second as. So it means that this equation is homogeneous, this equation is consistent, and in this way we will check the homogeneity of equation. Because this is one type of question, one type of equation. Now let us practice one more equation. Let's say I have V is equal to U plus GT. So let me name the variable. V is initial velocity, and oh my bad, not initial. V is not initial, it's final velocity. Sorry for that. V is final velocity. U is initial velocity. A is acceleration. And T is time. So that's how we know the variables now. Let's start this analysis. First of all, we will take the left hand side. On the left hand side we have V, it's the final velocity, the unit will be meter second minus 1. Now let's take the right hand side. On right hand side we have U plus AT Forgive me, this is A, not G. I have written it as G, so it's A. So U is velocity. We are going to solve it now. It will be meter second inverse plus the acceleration. The unit of acceleration will be meter second minus 2, and the unit of time will be s. So when we are going to further solve it, meter second minus 1 plus meter second minus 2 plus 1. So minus 2 plus 1 will become meter second minus 1. Sorry. So meter second minus 1 plus meter second minus 1, when we add 2 units, the answer is also a unit. So we have 2 meter second minus 1. We will neglect the 2. 2 is a number here. It will not involved in the analysis. We can neglect the 2 here. So we will have on the right hand side only meter second inverse. So you can see that on the left hand side we have meter second inverse. On the right hand side we also have meter second inverse. It means the second equation that we are doing is also homogeneous, or it is dimensionally consistent. This equation is correct. So that's how we are going to check the homogeneity of equation. And in CIE, the examiner will give you these type of question. This is one type of question. The other type of question that I have highlighted here in my video, we are going to practice this in the next video or when we are doing the past paper analysis. So that is all for this video. See you soon in the next video with a new topic. Until then, take very good care of yourself. Goodbye.